The question we are solving now belongs to test series 2. It is of analog electronic subject. In specific, it belongs to DC biasing of BJTs. As per the question, there is a transistor circuit given which is as shown in the figure. It contains a 58k ohm resistor and a 42k ohm resistor whose series connection point is connected to a BJT as shown in the figure. The emitter of BJT is connected to a 10 kilo ohm resistor and the collector is connected to the input supply directly as shown. The supply is 24 volts and it's also given that the current gain of the transistor is beta is equal to 125. We need to find the Q point values, that is ICQ and VCEQ, as per this problem. For finding the Q point values, first let us convert the points connected to the base by its Thevenin's equivalent. So upon finding the Thevenin's equivalent, we see that the circuit gets simplified as shown. The emitter is connected to 10k ohm resistor as before and the collector is connected to 24 volts supply, but the input supply and the base circuit part is connected to a Thevenin's equivalent, upon which we see that the Thevenin's voltage is 10.1 volts and the Thevenin's resistance is 24.36 kilo ohms. So from this is because of the reason that Thevenin's resistance is 58k in parallel with 42k and the Thevenin's voltage is 24 multiplied by 42 divided by 58 plus 42. The top one, which is a Thevenin's resistance, gets evaluated to 24.36 k ohms and the bottom one, which is VTH, gets evaluated to 10.1 volts. Now from this we see that for finding the Q point, the circuit gets simplified as shown. Now upon applying KVL to the path or to the region marked in the figure, we see that 10.1 is equal to 24.36k multiplied by IB plus VBE plus 10k multiplied by beta plus 1 IB. Here we know that VBE is equal to 0.7 volts and beta is equal to 125. Upon substituting for these values, we see that IB, which is IBQ, gets evaluated as 7.32 microampere. From this we can get the Q point values for ICQ as ICQ is equal to beta times IBQ. From the given data, this is 0.915 milliampere. Hence the current IEQ can be obtained as beta plus 1 times IBQ and this gets simplified as 0.922 milliampere. So from this we can get the VCEQ as 24 minus 0.922 multiplied 0.922 milliampere multiplied by 10k. This is by applying KVL to the region marked. So this gets simplified as 14.8 volts. From this we see that the Q point values are ICQ, which is 0.915 milliampere, and VCEQ, which is 14.8 volts. Hence we see that the correct option representing the Q point is P.